Without a doubt, keen life exists somewhere else. The odds are only excessively perfect for this not to be the situation. Following a recent revelation made by renowned science communicator Bill Nye, scientists and space enthusiasts are intrigued. This brought up a lot of concerns, including the nature and origin of the objects. It is essential to keep in mind that the Voyager missions have provided us with some of the most remarkable views of our solar system over the course of nearly 50 years, as we work to decipher the mysteries left by Voyager 1's astonishing revelations. Surprisingly, these missions, which were launched in the 1970s, were originally intended to last just 5 years. The Voyager missions, on the other hand, have far exceeded these expectations because of a groundbreaking invention by Michael Minovich that allowed a spaceship to use the velocity of a planet to propel itself deeper into the solar system. In the late spring of 1977, Explorer 1 and Explorer 2 were sent off only half a month separated, with the essential objective of investigating Jupiter and Saturn. By effectively investigating these gas giants, they fulfilled their mission, but they did not stop there. After Voyager 2 made the first ever up-close observations of Neptune in 1989 and Uranus in 1986, the mission was dubbed the Voyager Grand Tour. The enduring Voyager spacecraft didn't give up and decided to pursue an even more ambitious objective: exploring deep space. 46 years later, Voyager 1 and Voyager 2 are still on their way to the farthest reaches of space to collect crucial scientific data. Voyager 1 had entered interstellar space in 2013, according to NASA. Interstellar space is the region between stars that is unaffected by the sun's magnetic fields or particles. It is much the same as going from a turbulent nearby planet group to a quiet, brilliant sky, or nature's hold. The story continued in 2018 with Voyager 2, which also explored this vast region. Astoundingly, just 2 rocket Explorers 1 and 2 have entered interstellar space from that point forward, and they have been examining the associations between the sun-powered breeze and the interstellar medium. Arranged 17.7 billion kilometers from our sun, Explorer 1 and Explorer 2 have been our fundamental wellspring of information on the heliosphere, a hindrance of protection around our nearby planet group. The sun's consistent stream of charged particles, known as the sun-oriented breeze, shapes and adjusts the heliosphere. Voyagers 1 and 2 have relayed valuable information about this celestial shield as our cosmic reporters. The heliopause, the formal boundary of our solar system, is where the solar wind ends and the vast interstellar void begins. However, this cosmic drama has more to it. NASA's Explorer shuttle have yielded significant new data about interstellar space. Cosmological rays, or mysterious particles, have been found to be 3 times more intense outside the heliopause than inside the shielded heliosphere, which is an important discovery. This distinction is similar to contrasting the quiet of a patio with the bustling action of a clamoring road. By combining data from subsequent missions with the Voyager's findings, NASA scientists were able to complete a picture of our sun and its intricate interactions with the interstellar space that surrounds it. Scientists at NASA were astonished when Voyager 1 made a low humming sound last year that was similar to vibrations seen in trace amounts of gas floating in the vast interstellar space. The power system that powers Voyagers 1 and 2 is powered by plutonium. However, as the plutonium ages, it produces less heat, which causes the Voyagers to lose power. Nicola Fox, the head of NASA's Heliophysics Division in Washington, D.C., emphasized the significance of the Voyager missions in the face of this cosmic challenge. She stated that the Voyager missions have significantly altered our understanding of the sun and its effects in a way that no other spacecraft has done over the past 46 years. NASA had to make difficult decisions about shutting down systems that weren't necessary, like the heater that was supposed to keep instruments warm in the icy space. However, all 5 instruments have been operating normally, exceeding expectations since 2019, despite the odds. Experts from NASA are baffled by the Explorer's continued operation in conditions that frequently freeze other spacecraft, adding to the brave pioneer's legacy. Scientists are baffled and awestruck by the heliopause, which separates the influence of our sun from the space between stars. It is moving and forming strange angles. The external edges of our nearby planet group are astounding stargazers with surprising way of behaving. The thought that the heliopause is moving isn't entirely new. Sharp scholastics have noticed its penchant to adjust utilizing information from NASA's Interstellar Limit Traveler satellite, Explorer 1, and Explorer 2. These spacecraft are significant because they enable us to directly measure these cosmic frontiers, despite their limited presence in space and time. A space physicist from Princeton University, Eric J. Zerbichon provided fascinating details regarding the method by which the Interstellar Boundary Explorer IBEX satellite is providing useful data that scientists can use to make better predictions regarding the upcoming movements of the heliopause. What we previously believed to be true has been called into question by recent research. In 2014, IBEX identified an odd lighting up of fiery particles that might have shown a few anomalies in the heliopause, yet these inconsistencies didn't accommodate our previous models, practically like an unexpected development. In addition, after analyzing data from Voyager 1 and Voyager 2, researchers observed rapid and significant shifts in the position of the heliopause. This development could make sense of why these two tests arrived at interstellar space in 2012 and 2018, separately with a major in the middle between. Not only are these unexpected behaviors perplexing, but they also go against what we thought we knew about the heliopause. In a new article in Nature Astronomy, researchers alluded to these errors as perplexing, and they could cause some discussion in established researchers. However, don't worry. The search for answers will continue. Researchers are anxious to advance more from NASA's forthcoming Interstellar Planning and Speed Increase Test, IMAP, booked to send off in 2025. The advanced satellite promises to reveal additional secrets about our solar system's outermost regions. Up to that point, we can ponder the secrets sitting tight for us past the heliopause. In May 2023, Explorer 1 encountered a surprising occasion during its customary tasks. The piece of the shuttle liable for controlling its high-gain radio wire, known as the Disposition Explanation and Control Framework, AACS, began sending back befuddling information. It appeared that Voyager 1 was having trouble communicating effectively instead of the usual updates on the spacecraft's health and status. This was similar to how someone with a condition like electronic aphasia might struggle to speak fluently. Voyager 1 appeared to be experiencing electronic confusion from Earth's perspective. Interestingly, NASA claimed at the time that the data it returned was random or inconsistent, despite these odd observations. Explorer 1 appeared to be working as expected. Its radio transmission stayed solid and consistent, recommending that the receiving wire was as yet highlighted Earth rather than what the AACS was announcing. Despite the anomaly in the AACS, the scientific equipment on Voyager 1 continued to function flawlessly, and this incident did not activate the fault prevention system, which is designed to respond to malfunctions by placing the ship in safe mode. Luckily, NASA found the issue expeditiously. The AACS was found to be using a computer that had not been used in a long time. The issue was tackled with a basic guidance to move information to the functional PC. However, it was as yet hazy what had made the AACS act strangely. Although Voyager 1 posed no significant threat, NASA was concerned that an erroneous command from a different onboard computer might have been the cause. Voyager 1 has been exploring interstellar space for more than a decade outside of the Sun's protective magnetic field, which is comparable to Earth's magnetic field. NASA is looking into ways to prevent similar incidents in the future. The spacecraft's shield against cosmic rays and other radiation functions as a cosmic suit of armor in terms of technology. Voyager 1's onboard computers face cosmic obstacles just like Earth's computers might be affected by solar radiation and high-energy particles. Cooperations between enthusiastic particles and CPUs may once in a while bring about minor memory botches that collect over the long run. A cosmic perspective is provided by Susan Dodd, the project manager in charge of both Voyager 1 and Voyager 2. The spacecraft have been traveling for nearly 5 decades, far longer than their intended duration. It's quite important that they are exploring through interstellar space, a climate loaded up with elevated degrees of radiation and a region no rocket has at any point investigated. She specifies that experiencing such secrets is important for the standard at this phase of the Explorer mission. The incredible journeys of Voyager 1 and 2 began more than 50 years ago. During that time, they covered tremendous distances, investigated unknown domains, and found progressive data. These conspicuous spaceships stand up to an extraordinary trouble when they go into interstellar space. In order to function, the 1970s computer system still requires just 70 kilobytes of memory. NASA has figured out how to keep these far-away adventurers utilitarian notwithstanding mechanical constraints. Yet consider the work engaged with sending programming refreshes over tremendous astronomical distances to ensure they're proceeded with activity. It's like offering cosmic assistance. Consequently, the Voyager spacecraft, billions of kilometers from Earth, have crossed significant boundaries in the vast blackness of space, providing humanity with profound insights into the secrets of our solar system. We should stop briefly to respect these exploring space pioneers. In the midst of the stars, the two Voyager probes are currently saying their final goodbyes to our solar system. Each test is tantamount in size and weight to a little vehicle, similar to one-of-a-kind legends of room investigation. Beginning around 1977, these two rockets have been determined to uncover the miracles of room. During this notable excursion, they visited every one of the monster planets in our planetary group, found 48 of their moons, and sent back the very first very close photographs of Uranus and Neptune. At the point when Explorer 1 and Explorer 2 set out, their main goal's objective was to acquire a superior comprehension of Jupiter and Saturn. However, this task quickly developed into an ambitious exploration. These two daring explorers are responsible for a significant portion of our understanding of the solar system. Voyager 1 sent back images of the active volcanoes on Jupiter's moon Io, and Voyager 2 flew by Saturn's moon Titan in an amazing way. It was this experience with Titan that prompted an augmentation of the mission, which would before long be known as the Explorer Terrific Visit, carrying us nearer to Uranus, Neptune, and, surprisingly, further. Amazingly, none of this was done with cutting-edge video technology or advanced digital cameras. Standard film was used by the probes to capture this priceless footage, and it took 38 seconds to send each frame back to Earth. Each test is likewise furnished with a gold record containing pictures, sounds, and music from Earth. Would it be a good idea for it at any point be found by a high-level extraterrestrial development? The Voyager spacecraft set their sights on the farthest reaches of space after completing their exploration of our planet's neighbors. This is where they continue to travel to this day. They continue to send messages to NASA and occasionally receive responses. After 50 years, Explorer 1 is almost 24 billion kilometers from Earth, traveling north out of our planetary group, while Explorer 2 goes the other way, moving south. Beyond the planets and the heliopause, the boundary of our solar system, these spacecraft are venturing into unexplored interstellar space. NASA has carefully managed their power consumption as a tribute to their long service, allowing them to continue exploring the universe until around 2030. When their central goal closes, the Explorer tests will resign, floating through the universe as a demonstration of humankind's undertaking and creativity. Indeed, these two spacecraft have done something remarkable. They have boldly ventured where no one else has. Regardless of their age and distance, the Explorer space apparatus stay a demonstration of human interest and desire. The Voyager mission will undoubtedly continue to inspire future generations when we consider space exploration.